As you start a new project, the most important setting here is the one which says Compute Tangent Space per Fragment. In short, if you are using Unreal Engine, you need to set it on, and if you are using Unity, you need to set it off. To further elaborate, there are two popular techniques used in 3D graphical programming for creating the vector which is used to define the vertex normal. Each vector is defined by three component parts, and each component part is responsible for setting the distance from the origin in the x-axis, y-axis, and z-axis. However, it is possible to leave out the z component to save memory per vertex, since there's only two components stored in memory per vertex instead of three. The presence or absence of the third component is the defining difference between the two techniques. When using three components, the z component can be set freely, unrelated to the other components. However, when the z component is not read, an upward-facing vector is created on the fly at the crossing point of the other two components, usually with a 1.0 length. The difference here is that we can no longer set the height angle freely anymore, because it is set to a constant 1.0 value. But that does not mean that the height angle of the vector is always the same. When we move the x and y component closer to the center, it changes the height angle because the component which sets the height is at a steeper angle from the origin. Moving it further away lowers the angle. The two techniques results in vastly different normal maps because the normal map is baked to conform with the vertex normal. In other words, related to the x, y, and finally the z component. If the modeling environment sets the vector through three defined components, but the texturing environment reads only two of the components, it changes the vertex normal of the object within the texturing environment from what it originally was before. This is because the z component is most likely set higher. So if you send the baked normal map back to the modeling software, the normal map will not be compatible with the object's vertex normal within that software. If the modeling and texturing environment sets the vertex normal by three components, but the rendering environment sets the vertex normal by two, you get the same problem. To make sure your normal map is projected correctly, you need your modeling environment, texturing environment, and rendering environment to generate the vertex normal at the same angle, which means using the same method for setting the vector. This checkbox informs Painter of which of these techniques to use when generating the vertex normals for the imported model to make sure the normal map is compatible with the rendering environment. So what you need to check for in the online documentation of your rendering environment is if it defines the bitangent, which is the z component of the vertex normal, in the vertex shader or in the fragmentation shader. If all three components are defined in the vertex shader, set the button to off, and if the bitangent is calculated outside the vertex shader, set it to on. And again, if you are using Unity, set the button to off, and if you're using Unreal, set it to on. Moving back to the top, we find a set of templates. Templates loads in different shader models and sets up a bunch of shader channels to send data over to said shader model. These channels can be found listed under the texture set settings, where you can add and remove channels as you wish to fit any special needs. These templates are set up to work with the majority of the popular rendering environments, so it is rare that you will find a need to do so. Most of the templates has a PBR prefix to its name, which is an acronym for physically based rendering. Most of the major licensing game engines these days uses PBR shaders, but there is no set-in-stone ways of interpreting the data, and thus most game engines and other rendering environments use their own methods of doing so. The PBR templates are not really vital when it comes to exporting textures out of Painter, as it can convert maps back and forth to suit any export needs, indifferent to which template has been used to actually create them. However, it is convenient to stick to one template over time, especially when you start making smart materials. This is because the layer channels will only connect to texture set channels it has been set up for. So a layer which has been set up for a roughness channel in a albedo metallic roughness template will not automatically invert the roughness channel input and plug itself into the glossiness channel within a albedo metallic glossiness template. By sticking to one template, all your smart materials will work together without sabotaging the layer hierarchy. So even if you'll eventually export for Unity, which uses a albedo metallic glossiness model, you can just as well use a albedo metallic roughness template, which is used in Unreal Engine 4 and vice versa. But take note that the baked textures meant for Unity are not compatible with Unreal Engine 4. You will have to flip the compute tangent space per fragment checkbox and rebake the textures to make the normal map truly compatible. This can be done by going to Edit and Project Configurations. There's also some other parameters here that you can change, which you will go through in a minute. But if you have made changes to your model within your modeling software, this is also where you can reload your model to have these changes take effect in Painter. Model properties, which can be updated, are model geometry, UV layout, and materials. But you need to actually click the select button, select the file, and open for it to actually reload. The normal map format allows you to choose between the OpenGL method and the DirectX method for interpreting the tangent y value of the vertex normal. OpenGL and DirectX interpret the tangent y value oppositely. So what this normal map format really asks is if the tangent y value 1.0 means upwards or downwards. If a texturing environment is set to a OpenGL method and has the normal map baked against that specific orientation, a DirectX rendering environment will shade the surface as if the light entered from the opposite direction, because it interprets the value oppositely. Most rendering environments gives the user the option to flip the tangent float value, so this setting is not really vital, but it is convenient for the artist to set or to get this right the first time, so the flipping switch will not be necessary later. So if your rendering environment uses OpenGL, use the OpenGL method and vice versa. Next up is the Create a Texture Set per UDIM tile checkbox. If you don't know what UDIM is, then you are not using it and you should set this to disabled. But to keep it short, the UDIM workflow creates additional UV ranges outside the usual single UV range, and the artist can then place UV islands into these other ranges and create textures unique to them without having to assign them to unique materials. The textures will not repeat, mirror, or clamp outside the ranges as they usually do. The convenience of UDIM is that it allows the artist to easily work with multiple smaller sets of textures, which combined into a single UV range would create a much larger and computationally intensive texture. For instance, instead of working on a 16K by 16K texture, an artist can instead work with 8 2048 by 2048 textures without creating 8 different materials and clutter the material hierarchy. Painter will create a texture set for each UV range that has a UV island in it. So in this case, it would create 8 texture sets. Not all rendering environments support it, so you will need to look that up before deciding on using this method. The document resolution sets the amount of texels generated within the width and height of the UV range. In other words, it sets the resolution of the textures. Take note, this has nothing to do with the texture resolution of the baked textures. It only has to do with the resolution of the textures in the layer stack. The size of the baked textures will be decided in the bake window later on. Finally, if you have used any other programs to bake textures, these can be imported and connected to the texture set to have a visual effect across the model's geometry, and also be used as baking data within Painter to further generate texture types. For it to be self-assigned to the various texture sets, this naming convention displayed on screen needs to be followed. First, you need to write the name of the texture set, or the material within your modeling software, followed by an underscore and the texture type name in small letters and separated by an underscore where needed. If you don't follow this naming convention, the texture files can be found within the textures shelf, where you can connect them yourself. Since I'm primarily an Unreal Engine user, I'll select the DirectX normal map format and compute tangent space per fragment. Now that the low poly model has been imported, you may start the baking process. You will find a Bake Textures button under the texture set settings. In the panel to the left, you will see some buttons which each represents a single texture type, with additional checkboxes within them. The checkboxes lets you decide individually between the texture types whether they will be baked or not, and the two buttons on top lets you quickly enable and disable all the texture types. Moving to the bottom, you can close the baking window, bake all the texture sets with the current setting, or just bake the selected texture set with the current setting. By clicking on the buttons themselves, you can adjust the baking setting for said texture types. The default settings for the texture type specific parameters are usually good enough to get you started, so these can be left as is. They are well documented in the online documentation, which is worth a quick read the next time you find yourself on a bus. The most important settings are the ones which are found in the common category up top. These are settings which affects all the texture types across the board. The output size is the baked texture size in pixels. Every texture type which is set to bake will be generated at this texture size. Dilation width clamps the color past the UV island border in the amount of pixels set by this parameter. This helps eliminating mipmap compression errors, filling holes in the textures as a result of UV skewing and other stuff. The higher resolution the texture, the higher this number should be to compensate. The Apply Diffusion button will interpolate the color edges in the texture and create connected gradients between them until it fills all the empty UV space. Dilation width, on the other hand, clamps the solid color without the gradient behavior, and is only to a set amount. This is where you will reference your high poly model sources to bake from. If you click on the file icon on the right, you can add one or as many high poly model sources as you want. You can remove them individually with the minus button. The Use Cage checkbox enables and disables the cage model function. By clicking the file icon, you can navigate to the cage file you want to use. Shortly explained, a cage model is a projection source reference for the rays that scans the surface of the high poly model to generate textures, which will be projected onto the low poly objects. There is a lot of do's and don'ts with the cage models, more than I can compress into this video, so you will have to look up literature and other videos which is made to explain these more in depth if you want to learn more of this technique. The max frontal and rear distance sliders sets the ray projection distance from the low poly objects if no cage model has been referenced and enabled. For the baker to be able to see the geometry of the high poly objects and create textures, the high poly surface has to be between the boundary of these two parameters. If the cage checkbox is enabled, these sliders has no function since you are using the cage geometry as a projection source instead. Relative to bounding box sets the max frontal and rear distance parameter to scale relative to the scale of the entire model instead of the individual objects. So each ray is projected from the exact same distance from each vertex. If a cage is being used, this parameter has no function. The average normal option is also relative to the frontal and rear distance parameter. If it is on, the projection ray will project on the average angle of the connected faces instead of the perpendicular angle of each face. This sets the angle of the raycast where both faces are visible even when the connected faces form a degree sharper than 90 degrees. Most of the time, you will want this to be enabled. The Ignore Backface checkbox tells the baker whether to continue or stop the projection ray when it hits the backface of the polygon. If it is unchecked, the ray will stop, and if it is checked, the ray will continue. This can be used to eliminate some ray projection issues. Match informs the baker whether or not objects within the low poly model should be allowed to scan objects within the high poly model reference that has non-matching names. If it is set to match by name, the projection ray from the object named head, mouth, teeth, low will only scan the object named head, mouth, teeth, high within the high poly model reference. However, the object head, mouth, tongue, high will not be scanned by the rays of the head, mouth, teeth, low object, as the name does not fully match. Match by name and cage work together, so the cages that overlap other objects will not have these foreign objects be visible in the baked textures of the low poly surface. This makes it a lot easier to iterate on a model, since there is no need to re-explode and realign it with the high poly model and stuff like that. The high poly model suffix and low poly model suffix allows you to tell the baker which words to identify when matching the high poly objects to the low poly objects. Take the example mentioned above. Since it is set to _high and _low, the baker was able to match the names of head, mouth, teeth, low and head, mouth, teeth, high and isolate those two objects. The suffix strings allows you to set the suffix to your own preference, in case you have your own naming conventions you like to follow. Take note that the ambient occlusion ray will ignore this setting and occlude light across different objects as per usual. This is because the ambient occlusion ray uses separate rays for this task. If you don't want to occlude light between objects, this can be disabled in the ambient occlusion texture type setting by setting self-occlusion to only same mesh name. The anti-aliasing method increases the number of texels in the UV range by a set multiplication to further refine the detail during the baking process. It then finds the average color shared between these smaller points and uses it to color the actual pixel. This lessens the zigzaggy look between high color contrast pixels, as they instead use the middle ground within the area. Increasing the anti-aliasing factor will increase the time for the baking procedure. When you're baking your model for the first time, it is wise to turn anti-aliasing to off and disable all the texture types but the normal map. Especially the thickness map takes a long time to create, and it is a waste of time to wait around for it if it turns out there's something wrong with the projection distance or cage model. Keeping the texture size at 1024 x 1024 and the anti-aliasing to none will result in a very jagged texture map, But the only thing you should care about now is that the projection rays does not render foreign objects into parts of the normal map where it doesn't belong. Once you got a successful bake, you can enable the other textures and increase the resolution and the anti-aliasing factor to get cleaner or clearer textures.